I'm going to talk to you today about SQL Med, if my laptop catches up. For those of you who don't know me, I just do Postgres all the time. That's pretty much it, really. Involved in a whole bunch of different areas of the project. And lucky enough to get paid by Enterprise DB to do so. Center of my Dataverse. What are we talking about here? Well, it actually came about in a brainstorming session at work. We were trying to come up with ideas for a theme for our new release. And frankly, I just had this embarrassing marketing moment and thought that sounded kind of cool. The point being, though, that with SQL Med in 9.1, it really does kind of put Postgres in the center of the your Dataverse, whatever you want to call it. It allows us to talk to other database systems. So you can get to the point where, in theory, we can start to do pretty much everything we want through Postgres. Why do we want to do that, though? Well, you might be wanting to integrate multiple applications together. One of the things that I used to do an awful lot of in my past lives working, before I worked for Enterprise DB, was cross-database reporting. We'd have a rent accounting system and a general ledger system, for example, so we'd need to do reporting that access both databases. That could be kind of tricky. SQL Med makes it pretty easy. Data migration, moving data from one database system to the other. Perhaps you're moving to a whole new system, or maybe you want to offload and restructure some data onto a reporting system for data warehousing purposes. We can also use SQL Med for data sharding. You can, if you've got a very large system, you can split the data across multiple database servers and use stored procedures or application logic or some method for accessing data that's sharded across multiple different servers. And the pretty cool thing about it is they don't even have to be Postgres. You can have Postgres as the main application database, and you can run those shards in Redis or CouchDB or, God forbid, MySQL. And similarly, database federation. So, a little bit about what SQL Med actually is. It's the SQL standard for the management of external data. And I doubt anyone really cares, but it's defined in ISO/IEC 9075-9 2003. And basically, it defines the standard for how one can access remote data sources from within an SQL, a relational SQL database. So prior to SQL Med, so Postgres 9.0 and earlier, I guess, we'd have various different ways of accessing the data in remote databases. We can still do all of this, of course. You might use the copy command, which can either be a client-side copy or a server-side copy. You might use PSQL scripts. Or you might use custom loader programs. You hack something together in Perl or C++ or Python or whatever your language of choice is. Other systems may use stored procedures and stored functions. PL Proxy, for example, which is part of the Skype SkyTools package. Really, that's for advanced partitioning and data sharding. DBI Link, which David Fetter tends to work on quite a lot, I believe. So that uses views and functions and rules to make remote tables on a variety of different databases look as if they're local tables. And DB Link, which is a Contrib module which ships with PostgreSQL and allows you to access other Postgres servers from within, or databases from within the one that you're currently connected to. Sorry, was there a question at the back? Or, oh, I was sending you to sleep. So, the disadvantages to using such a system, you've got to write custom code. you may need to run batch tasks to do incremental imports periodically. Data may not actually appear as relations when you try and access it through SQL. You know, you might have to make calls to stored functions to get at it. You might actually need to create custom stored functions to access the data. And frankly, depending on what different data source you're trying to access, you may have a different interface to get to the data. So things become a lot easier with SQL Med. For a start, the data is presented to the user just like any other table. You can do select star from my remote table, and it'll behave exactly as it would if it was a local table. We have a standardized set of object types and configuration commands that we use to set up and configure the remote data source. They work pretty much the same way no matter what the remote data source is. You just have some options that are specific to a certain type of SQL Med interface. We've got integrated credential management, so you can securely deal with usernames and passwords and associate credentials with each database role. So you can say that, you know, user or the role public can use this username and password, and everybody just uses that to access one particular data source. For another data source, each individual user may have their own username and password that they have to use to access the remote data. Finally, we've got much deeper integration with PostgreSQL's Planner for improved query planning and optimization. Because SQL Med is built right into the server, we can actually make the planner aware of it rather than just presenting it with a set of functions that it really knows nothing about. So as the technology advances and as we get better at building some of the objects that I'll show you shortly, we can give Postgres more intelligence about how expensive data is to access on the remote data source, which can help it plan the queries much more effectively. This is version 1 of our implementation of SQL Med, of course, so there are limitations. You know, we haven't reached feature completeness, of course. We probably never ever will, but the major issues at the moment is that SQL Med is read-only at present in Postgres. This is something that's being hopefully looked at for version 9.2. That's fine for many use cases. You know, if you're doing reporting and whatever, as I mentioned earlier, or importing data, that sort of thing, you really only need to read it anyway. But obviously there are advantages to being able to write data as well. We have some planner limitations at the moment. One of the things that wasn't developed for the first version was an API for dealing with what we call qual pushdown. So that's, for example, if you do a select star from remote table where ID is greater than 10. At the moment, Postgres has no defined API for taking that where ID is greater than 10 and pushing that down to the remote server. So there are ways you can make it do it. There is an FDW where I've done a sort of test implementation of that sort of technology. But what we really need is a defined API where Postgres exposes in a standard way all the qualifiers so that we can offload that work to the remote server rather than just selecting all the data from the remote server and then letting Postgres apply the quals locally. Similar to that, we have no join pushdown. So if you're doing selects from two different tables that are both on the same remote data source, obviously you can make that more efficient if you can make the remote data source handle the join. Tom? Sorry? At the moment, no. Postgres itself doesn't have a specific API for you to access the data. If you know what you're doing, you can poke around in some of the data structures and extract it. I've done that on one FDW sort of experimentally, but as Tom Lane kept reminding me, those data structures may change in the next release. There's no sort of contract that says we're going to keep those particular things stable. So that's what we're looking to get in 9.2 is a defined API so that we can get at that data and we know that it's not going to change in 9.3, 9.4, and so on. Yeah, so this is the low-level internal details. And we'll cover some of that later on in the talk when I go through some of the details of how we actually write FDWs. So another issue that I picked up whilst I was working on this is there are two particular sections of the Postgres code, the planner and the executor. So the planner is the part that plans the queries and figures out how to structure the various reads of different tables and joining them together and that sort of thing. And the executor is the part that actually goes and does that. Currently, there's no way to actually pass complex data structures between those two parts of the system. What that means is it's kind of ugly. So if you need to open a database connection to the remote data source to plan the query, there's no simple way of passing that opened connection down to the executor part. So you either have some horrible kludges or you end up closing the database connection and then reopening it when you actually want to go and grab the data, which is kind of inefficient. So how do we use SQLmed? So we have a number of different SQL objects. First of these is the foreign data wrapper, which defines the type of remote data source. So, I mean, that might be an FDW for MySQL or for Twitter, or there's a whole bunch of them that have been written already. We'll look at some in a minute. The FDW consists of basically two functions, which I've written in C. The handler function and the validator function, which is optional. We actually use the term foreign data wrapper to refer to both the SQL object itself and less formally the binary code that actually implements a specific interface to a remote data source. So you'll hear us talking about creating the FDW in the database, and the actual modules themselves we refer to as FDWs as well. So just give you a few examples. This is a fairly complete list of all the ones that were known that I knew about a couple of weeks ago. I've written a MySQL FDW. I also had a student in the Google Summer of Code this year who's written an ODBC FDW, so you can use any ODBC driver in theory and access data through there. Lorenz Alb has been working on an Oracle one. We've got some NoSQL ones as well. My student, again, worked on CouchDB, and the very first one that I wrote was a Redis FDW, which is really pretty simple. That's the one that includes the experimental qual pushdown support, where I'm poking around in the data structures that Tom keeps telling me to leave alone. There's a couple of file FDWs. We don't just have to access remote databases. You can access things like CSV files or fixed format files. So we have a CSV, fairly basic CSV FDW included with Postgres 9.1 as a contrib module. And Andrew Dunstan's written a text array FDW, which reads ragged CSV files and presents them as arrays of text strings. And a couple of other less obvious types of FDW, one for accessing LDAP data and one for accessing Twitter streams.
There's also one for S3.
There's an S3 one now as well. Oh, cool. That could be interesting. Okay, so to actually use the FDW or to create the FDW, I mentioned there are two functions. So we have some pretty straightforward create function calls, which we run at the SQL level. They're really pretty standard. They're just creating a SQL level function that's pointing to some C code in an object file. And once we've created those functions, we create the actual FDW itself, which is the definition. So in this case, this is saying I've got this creating an FDW called MySQL FDW, and I can use that to access whichever MySQL databases I'm going to want to. Now in Postgres 9.1, I think David just mentioned this in his talk, we have a new extensions mechanism. So actually we can shrink all those three statements if the author of the FDW does his job well, down to create extension MySQL FDW, which is obviously a lot easier to remember. Once we have an FDW, the next thing we need is a foreign server. So the server, if you think about it in terms of a relational database, the FDW is the database type, the server is the physical server instance, a Postgres cluster or a MySQL installation, or a Twitter account or a specific file. Every server uses one FDW, and one FDW can obviously support multiple servers, so you can talk to data on 23 different MySQL servers all at once if you want to. Creating the foreign server again is just a single SQL command. I'm using my MySQL FDW as the example here. So we're going to create the server object, we're telling it which foreign data wrapper to use, and we're giving it some options. The options are defined by the FDW itself. In the case of the MySQL one, all we want here is the address of the server and the port number that it's running on. The next object we need is a foreign table. Once we've connected to our MySQL database, or created the objects to connect to our MySQL database, we need to define the objects that will appear as tables within our database, and obviously specify what they point to, if you like, in the remote database. So that could be the actual table in a remote Postgres or MySQL database, or a view, or it could be a delimited file, or it could be an SQL query that returns a result set, which then will appear as a table when we query it in Postgres. Similar to the foreign servers and the FDW itself, each table uses one foreign server, and each server can have multiple tables defined against it. What we end up with at the end of this is an object, or is a foreign table that we can use just as if it was a local table. So we can write SQL queries like that without messing around using stored functions or calling the data or having to do batch imports or anything like that. We just run it on the fly, it goes and fetches the data and returns us the query results. Creating the foreign table, really straightforward. We have to obviously give it a name, and we have to define the data structure that Postgres is going to see. So simple example here, there's just two columns which are text data type each. And we have to tell it what server to use to get the data. The MySQL FDW supports a number of 3 table options. The name of the database, which is optional, and then we allow you either to specify a table name, in which case it creates a link just directly to the MySQL table, or you can specify a query. Now that actually is kind of a neat little trick. If you know that you're only ever going to access a certain subset of the data within that table, you can actually work around one of the qual pushdown problems at this point, because you can put a where clause in that SQL query. So for example, if you're creating a table which is just going to show financial records from 2010, and you know it's always going to be financial records from 2010, instead of specifying the table name, you can specify a query of select star from table name where year equals 2010. And that means whenever you run a query against this table, it's the MySQL server that will apply that qual to the data before it's returned to Postgres.
How are you dealing with authentication?
Just coming to that.
Oh,
So the next object that we have is a thing called a user mapping, which we use for dealing with authentication. So the user mapping is basically a per user object that defines usually a username and password, but really it's up to the author of the FDW what options that they want to specify in any of the table, the foreign server, or the FDW, or the user mapping. I mean, in theory, that you could include a path to an SSL certificate, for example, as one of the options. Each user mapping applies to one server again, and each server supports multiple user mappings. So you can specify for user Joe, use this username and password, for user Fred, use this username and password, and so on. And you can define those for public or for individual user roles or group roles. So you can obviously specify all of the, I don't know, the IT team use this particular user mapping, whereas Fred uses this one. Again, very simple to create in SQL. In the example here, we're creating a user mapping for me. So what this is saying is when user D page tries to access anything that's on MySQL SVR, the remote server, we use the username D page and the password foo. And, you know, for MySQL, that's it. We just want the username and password. Okay, any questions before we move on? Okay, writing FDWs. This is the fun part for me, and perhaps not the fun part for some other people. Depends where your interests lie. So I mentioned earlier that one of the things we must have is a handler function written in C. The purpose of the handler function is that it provides pointers to the callback functions within the foreign data wrapper, so that Postgres knows what functions it needs to call. So when it's doing the planning, it has a pointer to a function that can plan the MySQL parts of the query. Or when it needs to get a row from the remote server, it has a pointer to the function that can get that row for it. I don't know if you can you see that okay? There's not much I can do about it if you can't, of course, but I will put the slides up on the wiki. So this is obviously to fit it on the slide, I've had to chop out a few bits of code, but actually this is pretty similar to what you'd see in real life. Pretty straightforward C function. If you've ever written a C function that's an extension to Postgres that's going to be loaded as a SQL level function, you'll recognize the sort of standard calling conventions at the top. Basically what we're doing here is we're defining a data structure called an FDW routine, and then we're just filling in the various pointers within that data structure that will point to these functions here, which are what we're going to define shortly, and we will obviously have to implement in C. And then we return the pointer to that data structure. So Postgres basically then knows, for a MySQL server, it knows that it can call all of these functions to perform various operations. We also have a validator function. Again, it must be written in C. It's optional. It's up to the FDW author whether or not he wants to write it. It's a pretty good idea because it'll help stop users making mistakes. And the purpose of the validator function is all those options that you saw on the previous slides when you do create user mapping and it's asking for username and password, or address and port when you create the server object. The purpose of the validator function is to ensure that you've got the right options set for each of those different SQL object types, and that the values are sane. So I mean, it's up to the author how much depth you need to go to do this validation, but basically it gives you a chance to check all of those options and to throw an error. So if you do create foreign server foo and set some options that don't make sense, the validator function can reject that definition and throw an error at that point and make the user fix it, and fix the SQL DDL statement. So here's a short, really, really, really compressed validator function. The validators tend to be quite long, but it's very boring, monotonous code because you're just iterating through all the different options and validating that they look vaguely sane. What happens here is you've basically got another function that's called by the database server. It passes us a list of the options and the values, and we literally just iterate over the list, validate whether or not we think it's a valid option. So that might be checking that the host address actually looks like an IP address, or that the port number is an integer. Or in the case of our foreign table for the MySQL FDW, you can specify either the table or the query to get the data. So our validator here will check to make sure that the user hasn't specified both. Because if they have, what do? So we need to reject that and make the user create the object in an unambiguous way. So once we've created the C-level functions that are loaded when you do the create extension part, we actually need to create the functions that we provided the pointers to in the handler function. The first of these is plan foreign scan. So what this is going to do is it's going to generate the plan, or the access plan for how we're going to get the data on the remote server. In reality, it may or may not do anything remotely. It may not actually do much locally at all. But the key thing that it does is it returns cost estimates to the Postgres planner. So this is your chance to figure out if this is going to be an expensive SQL query to run, and to tell the Postgres planner that, so that it knows to favor accessing, to generate the plan in a different way if it means that it can access this table less frequently to execute the query. So in the example here from our MySQL FDW, what we do is we connect to the server. We're going to do a very simple select count star from the table that we want to access. And then we set the rows value in one of the data structures that we're passed to the number of rows that the SQL query returns. We then do another little test and we say, okay, is the MySQL server running on the same machine? Is the IP address 127.0.0.1? If it is, we can set the startup cost at 10, or rather leave the startup cost at 10. If it's not, we can say, okay, it's a remote server, it's going to be a little bit more expensive to start the connection, so we'll just add to the startup cost. And that just tells the planner again that it's going to cost a little bit more in terms of CPU time, whatever, to actually connect and begin executing anything from this remote data source. And then we just return that data and then leave it up to the planner how it uses that information. The next API that we have to create is explain foreign scan. This really does nothing useful to executing the query whatsoever. What it does is it gives you a chance to add additional information to the query plan output. So if you do an explain select star from remote table, it gives you the option as the FDW author to add some information and say, well, I'm going to add a certain amount of cost to the startup cost because this is a foreign server rather than a foreign server on a remote machine rather than a foreign server running on a local machine. So this is purely about giving the user extra information if they run explain. In the example here, we do exactly what I just said. If it's a local server, we just add a little text string that says it's a local server, the startup cost is 10. Otherwise, it's a remote server, so our startup cost is 25. Those are just arbitrary numbers that I plucked out of thin air. Obviously, as you develop an FDW and you learn how to estimate the costs and tell Postgres usable numbers and usable values for those costs, you can tune your code. Next, we need a function called begin foreign scan. Basically what this does, we're now moving into the part of the FDW that the Postgres executor will call. In this case, what we're doing is we perform basically initialization for the foreign scan. Tom tells me that should be very lightweight. Typically we don't create remote connections there. We just initialize data structures and get ready to do the scan on the remote node. That said, I do connect to the database server in one of my FDWs. So we're setting up the connection there. MySQL, it's fairly lightweight to connect to a remote database. I probably wouldn't do that if it was Postgres, where there's a fairly high startup cost when you create a new connection. We're creating the query that we're going to run remotely, and we're creating a data structure that we're actually going to use to keep track of the state of the scan as we access the remote data. So that data structure is going to do things like it's going to hold a pointer to the MySQL connection. It's going to hold a pointer to the result set that's holding the MySQL, the rows that have come back from the MySQL server. And as well, it's going to hold pointers to things like the query as well. And what we do with that data structure is basically pass it to all of the functions that we're calling from this point on, or rather that Postgres is going to call. The next function is iterate foreign scan. The first time this is called, it's going to actually execute the remote query on the remote database. And then on subsequent invocations, it's not going to do that again, but it's going to keep returning one row or one tuple every time it's called. So Postgres basically, every time it needs another row of data from the remote data source, it's going to call this function. And our job here is to provide that data. So if we don't have a result here, that's in this data structure that we're passing around, FE state. If there's no result in there already, then we haven't run the query yet, so this must be the first invocation. So we run our query, then we fetch the first row. If we've got a row, what we're going to do first of all is convert the MySQL row into a Postgres tuple, and then we store the tuple in a slot, which is an internal data structure in Postgres, and then we just return that. Then on subsequent calls, we've got the result structure already, so all we do is we fetch the next row, create the tuple, create the slot, and return it again. And when we run out of rows, we just return an empty tuple slot, and Postgres knows we're done. The next couple of functions are really pretty straightforward. I mean, those ones I think we've seen so far, you'll agree, are not particularly complex. There's no black magic in there or anything like that. But we have a couple of extra functions here. Rescan, foreign scan is used by Postgres basically to tell it, rewind the scan to the beginning. So I've never actually seen this happen in practice. I suspect it might happen if you're using cursors. In this case, all the MySQL FDW does is basically clears the result set. So it just resets it to beginning. So next time the iterate function's called, it's like we've started over. We've basically just rewound it all and reset. And finally, we've got end foreign scan. This is essentially the cleanup at the end of the scan. So Postgres will call this when it's finished with the data on this remote table. And our job here is literally to go through and just clean up all the data structures we've created, disconnect from the MySQL server, discard the query results because we've returned them all now. We know Postgres doesn't need them anymore, and basically free any memory that we've used. Any questions? Yes. You would need to handle the errors within each individual API function. I mean, my code here is obviously vastly simplified, so I can store it on there. But in iterate, for, and scan, what you would do there is if you detect a connection error, at that point you would just reconnect. And you'd probably have to rerun the query. Or you could throw an error up to Postgres and say disconnected, which will just tell Postgres to stop processing that query because it knows there's been a problem. That's probably the safest thing to do, because if you rerun the query, you don't know that you're going to get the same results the second time, of course. Okay, okay, so, wow, I think I'm doing okay on time, actually. I was a little bit unsure because I've got a lot more slides than I normally have for a talk of this length. So I'll run quickly through some examples and just show us using an FDW from start to end. First thing we're going to do, create the objects, create extension MySQL FDW. Just running this in pSQL here, even though I'm the pgadmin guy. Then we're going to create the MySQL server. So we specify the foreign data wrapper that we're going to use, which is the MySQL FDW, and our address 127.0.0.1, and the MySQL server is running on port 3306. Then we create a foreign table called employees. We give it the data structure that we expect to find in there, which is an ID, which is an integer, person's name, which is a text field, and the person's address, which is another text field. We're using the MySQL server as the foreign server to access the data on. And we're specifying that the remote table name is hr.employees, so a table called employees in the HR schema. We're going to create another foreign table, this time called overtime 2010. ID is an integer, employee ID, which is a foreign key to our employees table, is another integer, and the number of hours is another integer. Again, we're using the MySQL server. This could be on a completely different server, of course, this data, so we might be getting this from an Oracle database somewhere or some other data source. In this case, the options that we're specifying, instead of specifying the table name, we actually specify the SQL query to return the data that we want. So just a select ID, employee ID, and hours from hr.overtime, where year equals 2010. So, as I said earlier, what that means is that all effectively the qual push down, the where year equals 2010, that gets processed and handled by the MySQL server, so Postgres doesn't have to worry about it at all. So let's try it out. Select star from employees. And this is a real example. I haven't just typed this in. I did run this. And there we have 3 rows from my test table in MySQL. Which, as you can see, I mean, that's exactly what you would expect if that table was a local table with that data in it. We can run an explain on there. So explain select star from employees. We see explain is telling us that it's a foreign scan on the table called employees. The startup cost there is 10 because it's a local server, and you remember my MySQL FDW treats anything running on 127.0.0.1 as a local server and gives it a startup cost of 10. 3 rows, giving us a total cost of 13. And we've got the additional information, the local server startup cost, which was in our explain API function, and another piece of information that wasn't shown on that slide for brevity, where I actually just have the explain display the query that was run on the remote server, just for debugging purposes. We can do a slightly more complex query this time and actually do a join between these two tables. Now this illustrates what I was saying on one of the really early slides at the beginning, one of the things that's being worked on for 9.2. The ability to have this join actually push down so it executes entirely on the MySQL server. Currently what's happening is Postgres is actually going to run 2 foreign scans and pull the data back and do some kind of join locally in Postgres. It's more efficient, obviously, if we can push that join down to the MySQL server. And hopefully, I think I saw somebody posted a patch with an initial proof of concept for doing that to hackers just a couple of days ago. But in this case, again, fairly standard SQL query, just joining the two tables together, showing the employee names and the number of hours of overtime that they've worked, which of course is in 2010. And clearly I'm overworked. Again, looks very, very standard, just the same as if you were running it on a bunch of local tables. We can look at the query plan for that. Very, very similar to what I'm sure you've all seen before in Postgres, you know, nested joins, join filters and so on, materialization. The only real difference is that instead of doing index scans or sequential scans on tables, we're doing foreign scans. And we're just, again, just displaying that extra information that our FDW spits out for your own debugging purposes. This time showing that the remote query used on MySQL for the overtime table was a little bit more complex because we've got that where clause at the end of it. And that, after 42 minutes and 18 seconds, brings me to the last slide. Any questions? Yes?
Is there a Postgres or data wrapper? So, like, how you could replace DB Link?
Again, there was one posted just a couple of days ago to the mailing list, I think as part of the patch I mentioned a moment ago for the qual push down. I don't know if you've not been paying attention. Okay. I'll try not. But yes, I think we'll certainly see one very soon. So. Yes.
Postgres instances, and then we have another one that has like master tables for certain kinds of data. And currently, what we're doing to access that now, so just in the application code, we're just accessing the local and then separately accessing master with a connection. How would performance differ between using, if we linked master tables in using this foreign data wrappers? How would that be different from just doing? I mean, right now, I guess with the push down, would probably not be as good performance.
Yeah, you're not going to get as good performance without having qual push down, obviously.
Right.
I would say in an architecture like that, you're probably not going to get as good performance as you are at the moment because obviously your application ends up talking to one server and then that ends up requesting data from another server,
Right.
which is clearly going to be less efficient than requesting it from 2 different servers in parallel. The advantage to doing it that way, of course, though, is that you don't have to write your application with awareness of how you've sharded your data.
Right.
You can hide all that away on the master
Right.
server.
In ways that, like, if we want to join things, that would be much easier to just do in SQL and not have to worry about.
Exactly, yes.
You know,
So
application.
it can make your application code much more simple and straightforward.
Yeah.
because you just don't have to worry about how the data's sharded or how things are split up between different systems.
And is there a plan to, when you do an explain, right now I see when it goes to the foreign data wrapper, it just says, oh, this is a foreign scan. Is there any plan to try to pull in explain data from remote? Like, if for example, if we were doing on Postgres, does remote
Yeah,
know how it's doing it?
in the
That would-
plan foreign scan function that I showed, I was just doing a select count star to try and get some idea of how much data was going to come back from the remote server. One of the things I did mess around with on MySQL was, instead of just doing a straightforward count, running explain on the MySQL server and trying to glean some useful numbers out of that.
Right.
The problem is that MySQL's explain output is practically useless. So I kind of gave up in the end. For me at the moment, really, this is more hobby work rather than something I'm doing for
Yeah.
specific projects or business. So I played with it for a while, found that it was not going to work easily, and moved on with other features that were
Right.
more readily workable. So.
And I guess this would also be dependent on the data wrapper itself, but you tend to just close the connection between queries, like you don't cache connections to remote. So
Yeah, that certainly is dependent on the data wrapper. Mine
yeah,
are fairly new, and they, like I say, it's just been written by me for fun. But
yeah,
certainly having some mechanism for pooling connections and caching them.
right.
I mean, we do that in other projects I work on,
Yeah.
like Postgres Enterprise Manager, for example,
Yeah.
where we're very aggressively caching connections.
Right.
Particularly with Postgres, where the startup cost is quite high for creating a new connection. It's important to not be creating them every time you want to scan a single table.
Yeah, I imagine that also be a good option to say whether you want to cache it in the future. But
Yeah, it would be entirely up to the author of the individual FDW. Any other questions? No? Okay, well, thank you very much.